20, I'll call it a day. Yeah, it's not really realistic, is it? Yeah, I'm getting all up in Mongo there. I don't want that.
We're getting to 12 now.
Okay. How am I at? 11.
A little lateral.
Yeah.
Which way is the lateral that helps?
They both help a little bit,
Okay.
but lateraling to port helps the most. Okay. Yeah.
That was with the starboard bio, though, right?
We still
Yeah.
have
Still
something there.
something there. Yeah. Can I see camera right, please?
I never get into bed.
Thanks, Trevor. That's okay. I am a low sitter. I definitely am the person, one of the people who lowers that chair. So we're coming up at about 12, which is not terrible. It just took a while to get to that point. I threw a little bit of yaw on, or a little bit of lateral on, and it didn't hurt. I have only the tiniest bit of horizontal on. Do you think I need an auto head on? Do you usually take that off?
Yeah, they're coming up very slowly.
I have stick lock on right now.
434 feet. All they're gonna do is.
Okay, so I did. This is what I've done: forward and to port, and not that much because I don't have that much to spare. Yeah. Yeah, I understand. Yeah. There we go, nice. So I think part of the key of that was getting rid of the auto head, because I think auto head was using up some of the... Yeah. Okay, nice. Good job, Greg. Way to optimize. That's about what I had for horizontals, but that's way more lat than I had.
All right.
Someone was wondering, is it possible to use the arms bilaterally?
Yes, and we do. Greg, can you come up, can you lift the Argus cam for a second? I just tried to do it from my screen and couldn't. Can you just do ignore stops? It thinks it's at the top of the software stop right now. There. Did you have to ignore stops to do it? Yeah, I don't know why it just decided it was in a totally different place. Nice, 15. You would? That's okay. Okay. Yeah, 16. Nice. Yeah, because we're going to have to go back the other way. Everybody watching out for 2100?
Eyes
Okay.
peeled back here.
We have porch light on.
So Wayne, have any of the instruments ever melted?
Greg.
I've never melted an instrument, but I've heard stories.
Okay. Somebody
I don't
else.
think I've ever melted an instrument.
The light?
Oh, I did melt the light. I mean, it's not melted, but it's a different color. The plastic is a different color than all the other lights.
Okay. Still functional, though.
I
Yeah.
can confirm it is still functional.
Yeah, still fully functional.
It's a good
you
light.
you were just being creative.
It looks a little bit different.
It does. But yes, around hydrothermal vents, you do have to be careful about vehicle positioning and specifically tether positioning when it comes to some of the hotter vent fields. Right. Yeah, I almost forgot about the light. Conveniently. Hurry up and wait. We have a pretty decent list of things to take care of when we get back to the surface. But I was just going to connect the wipe to a different camera and see if that worked, and then that would isolate the camera or whether it was a bigger problem. And then if it's a bigger problem, it's do we have enough time to deal with it? Important, yep. Yeah, it's these two, right? That one's real. That one is broken. Yeah, but brand new. Usually I'll just Z-bias the full 100. So that way you can unstick lock. Yeah. Almost. Go ahead and unstick lock. It'll be like a... And then you can just zero it at any point, right? And leave the rest of your stick lock on, or go into auto altitude or auto depth at any point and leave the rest of your stick locks on. Let's try more lat and maybe like 18% on the horizontals.
So for those of you following
yeah, that's good. We'll see what we get there.
on Nautilus Live, we are currently sending. The vehicles are on their way back up through the water column to the Nautilus. We've completed.
If we can hit 12 on this, we'll be good.
We've completed our first dive at the Gorda Ridge site as part of this 2019 subsea expedition. We have a pretty regular daily schedule. We hope to be getting the ROVs in the water at 4 a.m. each morning and then descending to the seafloor. And then around about, well, at 8 o'clock each evening, we hope to have the ROVs back on deck. So that sets the time we have to leave the seafloor, typically around 5:30 in the evening. Once the vehicles are back on deck, the work doesn't stop. The various teams that have been taking samples through the day will be looking at their samples, whether that be geochemical on a particular day or microbial, as I think some of the samples were taken today. The ROV pilots and engineers also have a pretty busy time when the ROVs are back on deck, just giving the ROVs the check over and preparing them for the next day's dives.
Oh yeah, we got a whole list of things to troubleshoot.
How long do you typically spend on it, Greg?
We can do a turnover with no troubleshooting in typically 4 hours.
Wow. But yeah, with a little bit of troubleshooting, I imagine that adds to the time considerably.
Yeah, yeah, it can.
Yeah. So just to kind of recap the day for you guys, what we've been trying to achieve today. This was our first dive of the subsea expedition. And so we're visiting this Seacliff hydrothermal vent site, but today was the first time it had been visited by scientists in approximately 13 years. What that meant was, first of all, we had to find the actual site. We had a few basic measurements to tell us the right depth to go to and the right area of the essentially undersea valley, the rift valley that we were going to operate in. But then we struck it lucky pretty early on. We found signs of tube worms and then the vent systems, and so we performed a visual map just delineating the limits of the hydrothermal vent system. We then had a really successful afternoon where we deployed a high-resolution sonar system actually on Hercules instead of the... Most of our viewers are used to the high-resolution sonar system we have on the underside of the Nautilus, but we had a mini system on Hercules, and we're able to essentially create a detailed high-resolution map of the whole hydrothermal vent site, typically with a resolution of about 5 centimeters. For those of you who are tuning in the afternoon, that was when it looked like we were mowing the lawn backwards and forwards. And then having completed that and wanting to make use of really every minute on the seafloor, we spent some time actually trying to start taking temperature measurements from the vents to characterize which are the range of temperatures we've got. We've got a few experiments over the next few days that require either low temperature vents, let's say between 15 and 50 degrees Celsius, and then other vent systems where we really want high temperature water in excess of about 200 degrees Celsius. So we did a little bit of mapping there, and also deployed a few microbial experiments actually over some of the vents. The idea here is that we expose sterilized substrates to the vent fluid and then recover them anywhere between 2, 4 or 6 days later, and then see what we can culture from those vent fluids, see whether we've actually entrained any bacteria that were living inside the vents in this substrate material. So a pretty successful first day all in all. So how about those of you in the back row in the control van? What were your impressions of today's operations? Hey there, back row. I was just wondering, are you guys joining us on SPL?
Yeah, we're here.
Okay. I was just curious what, here's some of your impressions of the day's operations. What were the highlights for you?
Yeah, it was really cool getting to see a bunch of the tube worms and that little octopus garden.
Mm-hmm.
So...
That seems a long time ago.
Yeah.
Who have you got there next to you, Ashley? I can't see around the corner.
Oh, so right now we have Lee as chief scientist, and we have Matt doing subsea things. So they're both busy reading the new dive plans for tomorrow's dive.
Ah, that's why.
Hi, John. Yeah, sorry about that. We were engrossed in reading, ready for our next meeting.
Nope.
But yeah, I'd like to say it was a really successful dive. I think we did really well to relocate the area of venting. I think we were very happy this morning when we were actually able to see some evidence of fluid flow, when we started to see the tube worms and actually located the the vents themselves. I think everyone was pretty happy to see that, and actually we knocked off quite a few of our objectives. So yeah, it's been a successful dive so far. It's been good.
No, that's great. Thank you. So keep your questions coming in on nautiluslive.org. We've got a quieter time here as we're ascending through the water column. This is our blue water stretch of the dive, and it's going to take anywhere between 2 and 3 hours to reach the surface again. Probably getting there somewhere between 8:30 this evening Pacific time. This is actually one part of our dives where we actually have a lot of time for you guys. So we can actually post the questions around the room as well. So fire away. So just for you guys in the back row, if you're listening, I just had a query from video about apparently you guys have some sample collection to do at 2100 meters.
Yeah, so we're taking a Niskin sample, which is basically a tube that has a cap at both ends, and so that'll just collect a sample of water at 2,100 meters.
Okay. Do you know what video you need for that? Just so Wayne was thinking he could prep it.
I am not sure. Lee, do you know?
We have all the videos. Well, right now the camera that we're really going to be using is off because it is a ground fault.
Sorry, what was
Okay. Oh, they were just trying to figure
But
out which video
we're
they
gonna
needed.
turn it on in time to do this and then turn it back off.
Okay.
Oh,
But it's port rail, starboard bio.
so I got a great question for you, Ashley, on
No, I don't
Nautilus
think we
Live.
need anything.
What does the data logger do?
Yeah, so basically my job is to take note of any important biological observations and geological observations. So whenever we come upon vent sites, I take note of that. I also take notes when we're taking samples. So when we were measuring the temperature earlier, I was taking note of the max temperature that we were getting. When we take this Niskin bottle sample for the water, I'll be noting that down. So basically anything important I take notes of.
And those notes
Data, are we taking all Niskins or just one Niskin?
So far I just know it's the one at 2100.
And
Okay.
we're gonna take 4. We've already taken 2, so I believe it's 7 and 8 have already been fired.
Yes, that's correct.
So yeah, so the rest of them, the remaining 4, once we get just shallower than 2,100, we can just fire them all, and you don't need to stop the vehicle either. You can just carry on with the ascent. They don't need to.
Perfect.
I didn't follow. Was that was
They
4 at 2100?
Yeah, they fired 7 and 8, so
Yeah.
we have to do 9, 10, 11, and 12.
Yeah, and you don't need to stop the vehicle in the ascent. You can carry on with the ascent.
And Ashley, when you take those notes, that's basically you have a logging system and everything is time-stamped so people can go straight back to the right place in the dive video, is that right?
Yep, that's correct. So then after the dive is finished, me and the other data loggers will go through all of the notes we've taken and we write up a dive report summary so that way people can go back through and quickly get an overview of what our dive was like.
Okay.
What's up?
How long does that typically take?
Port rail.
The
Yeah,
dive
port
summary,
rail, port bio.
I have not written one yet, so this will be my first one. So
Okay.
we'll find out.
You can tell me tomorrow.
Yep.
So another great question on Nautilus Live that we had is, are these vents associated with any fault lines, as in the Gulf of California vents? And that's really exactly what they are. What you can imagine is off the coast of North America, you have a series of, I guess, regions, let me say, where the various tectonic plates come together, junctions. There's, it's broken into a number of smaller areas, and we give each of the plates their own names. But essentially the Pacific plate is in this region meeting the Gorda plate. These two plates are moving apart from each other at what is, relatively speaking, a slow to medium pace. And what that separating movement creates is a huge undersea rift valley. It's about 3 kilometers under the ocean, but I forget the exact dimensions. It's maybe about 1 kilometer wide or so of a big rift valley with a small axial ridge running down the middle. And that ridge is kind of one of the zones of intense activity. We've actually been operating today at one of the hydrothermal vent systems that are on the sides of that rift valley. That's where we've been operating. And it's interesting because its distance from the center of the spreading center means you might normally expect there to be lower levels of activity, typically speaking, but this is still quite an active site. We're seeing vent flows up to a couple of 100 degrees Celsius. And importantly, a lot of lower temperature vent flows that we think could be sites for microbial growth and microbial communities. And so that's why we're really going to try and characterize both the geochemistry of the fluids coming out of these vents to actually characterize the environment and try and learn something about the heating mechanism under the rocks there. And also there's going to be biological experiments where we try and essentially capture samples of bacteria, either on substrates or in the vent fluid, and then grow them in the lab, and then be able to make in quite short amounts of time basic statements about what types of species are there, are we actually getting microbial communities, and yeah, it's a pretty interesting cluster of scientific goals that are linked to this particular geographical site.
Current ascent rate is approximately 14 or 15 meters per minute.
Okay.
So
should we do the maths?
somebody can do the math. We're about 10 minutes away from firing Niskins.
Okay.
Yeah, and the ascent rate is variable because we increase our ascent rate. Let's see, let's back up to vehicle setup. The verts are oriented within the body of the vehicle, and they are directly vertical. So when we are blowing water down, we're blowing it kind of through the vehicle.
Okay.
Which is not ideal for thrust. So one of the ways that we kind of assist with this is we will lateral because the verts are in line with the laterals, and so that way we're kind of taking that funnel of water that we're blowing down and kind of blowing out, so it's
okay,
not quite into the vehicle, and so but it's more effective in one direction than the other based on vehicle setup and other things in the body of the vehicle. So one direction we're getting like 15 to 17, and in the other direction we're getting 10 to 12.
Okay.
So average 13.
But I guess what you describe, it's like having the thruster is not pushing down on open water, it's pushing on Hercules itself, right. And so
right.
Conservation of momentum means you can't go anywhere.
Yeah. It adds to the challenge at least.
So one question I had, and I don't know if it's the right time to kind of expand upon that now. So you guys essentially have a kind of a cruise control for these ascent-descent stages, is that right?
We have an artificial cruise control, yeah.
Oh, is it? Okay, I think I see it there. Is it the big bar?
Yes. Right next to the sign that says, do not ever use a mechanical piece to do this.
Okay. So one of the neat things we get to do on Nautilus Live in these ascent-descent stages, because we've got much less operational pressure, we can really take your questions and bounce around the room. And one of the questions is, what was today's 4 p.m. snack? I wouldn't normally go into that, but today's 4 p.m. snack was pretty amazing. It was the chocolate chip Oreo cake, basically designed to put you into some kind of sugar arrest after about 10 minutes.
The raisins were healthy.
Oh, I didn't get a piece with raisins. I just got chocolate chips.
I couldn't identify it. It was just, it was a mound of chocolate nonsense is what it was. They're definitely trying to cause diabetes.
Delicious chocolate nonsense, though.
Yeah.
They are trying to cause diabetes, I'm convinced.
The good thing with full dives on YouTube now, we can go back to 10 past 4 when people came back into the room and actually see the sugar
Find
wave
out
pass around the room. Yeah, I'm sure we're going to find somebody in a coma with Oreo cake around their lips at some point on the evening.
I, for one, would not be surprised.
Let's see, what was yesterday? Yesterday was bread pudding.
Oh, now that got me.
That was a couple of days ago, actually. That pushed me over the edge just as we were on transit.
Yeah.
I felt a little bit, it was wonderful, but I just felt a little bit full, let's say.
I discovered it right before dinner time. I skipped dinner. I ate a bowl, and I was like, I'm done.
As you can tell on Nautilus Live, hunger is not one of the challenges we face on board the ship.
No.
So another great question, when will the next dive occur? So essentially we're hoping to have the ROVs back on deck shortly after 8 o'clock this evening. There'll be, as some people were mentioning, there'll be a turnaround of prepping the ROVs for the next dive and dealing with the samples on board. We do operate on this cruise a fairly regular schedule, so all being well, we hope to have the ROVs back in the water at 4 a.m. Pacific time tomorrow morning. There will then be another, let's say, approximately 3 hours of descent time. Actually, maybe a little bit less. We touched bottom this morning at about 6:40 a.m. Pacific time. And then we're typically on the sea floor till, well, today we left the sea floor approximately 5:20, 5:30, so we have a good long day of diving and a pretty exciting dive plan in terms of really starting to get up close and personal with some of these vents tomorrow and perform some detailed experiments around them.
This isn't, oh yeah, this is, just trying to remember which playlist I was on. Yes, I have heard the...
We've just crossed 2,200 meters.
Okay, so 100
meters to go.
Okay, thank you, Wayne. So the ROVs are just passing through 2,200 meters depth at the moment. When they hit 2,100 meters, we will activate a few of the Niskin bottles.
And then since the other way is a slow way, you might want to crank the lat, right? Slower this way, crank it this way. Dodger.
So when we activate those bottles, that's basically a sampling tube with a cap at both ends that allows the water to flow vertically through it. You'll see the manipulator arm will basically pull the release toggle for those caps, and they're designed to shut simultaneously, trapping water in them. That water is then taken off the ROV and processed to... I don't actually know what they're trying to get from the samples. I've never been there when they actually go through the Niskin bottles. Yeah. So if all goes well over the next, let me see, week or so, I think we have another 8 or 9 dives planned at this site, happening every day on a fairly regular schedule. In terms of the samples we're collecting, I'm not sure if we're going to be collecting, we will actually be collecting some biological samples. I think we plan to collect some tube worm samples, certainly a lot of bacterial samples. We've got a specially designed super sampler on board that allows us to essentially filter vent water and direct that to a number of cassettes where we can then capture and hopefully filter microbes from individual vent sites. But in terms of the large fauna, the macrofauna, I think just the ridge worms at the moment. The tube worms, sorry.
They're Regia, aren't they?
Yeah,
Regia
that's right.
worms. So you're pretty much spot on.
Yeah, that's why I get my... you'll find spoonerisms come into all of my commentary when I start talking too much. My best one was ticking clock became clicking talk.
That's a good one.
Yeah, that was quite a good one, yeah.
And dangerous.
Yeah, and well, I have to say thank you to all the folks on Nautilus Live for pointing it out to me.
Did they take the 2 easy ones? Nice. Yeah.
So there you can see on the just that side view of the Hercules camera what looks like a whole set of parachute ripcords. Those are the release toggles for the Niskin bottles. So Gabby, the Hercules pilot, is now just setting up, waking up the manipulator arm, the Craft Predator.
Yeah. Stretch it out, make sure it's limber. And
Do you want to try to engage the ground on the biocam?
yeah,
Yeah, definitely.
Bring that up.
So actually on the quad view on Nautilus Live, you've in the bottom, yeah, I see on the bottom left panel in channel 3, you can actually see the Niskin bottles now. And so as the manipulator arm on Hercules grabs each one of these pull toggles, you'll see each of those bottles snap shut. You can see a couple of them already snap shut. Basically inside there is a piece of stretch rubber tubing, and once the toggle is pulled and the pin is released,
I am.
they'll snap shut at top and bottom.
All right, I'm going to spin you. Or do you want to spin you?
Spin me?
Yeah, because...
Oh, is it time?
Yep.
It's time for the spin.
It's always time for something.
Sure is. Spin me. Crank it.
So we're just waiting till we hit the right depth figure before we deploy these Niskin bottles as requested. Sometimes the request can be pretty specific, actually to stop the ROV at a particular depth. Here we're just going to pass through 2100 meters and just pull each one in turn. So just in response to the question on Nautilus Live, my name is John Willis. I'm a Science Communication Fellow. I am not Samantha Wishnack, who is meant to be on watch duty, and you can see her photo at the moment. Her day started this morning at about 3:30 a.m. helping to launch the vehicles, and then followed by a 4-hour shift. So she's had a pretty full day. So some of the other science communication fellows are just playing tag and tag teaming it, sorry, and
All right, all you.
enjoying the blue water. So we're about to pull the toggle releases now. If you're in quad view, you can see the releases being pulled, and then you should see the Niskins
All right, go for it.
snapshot.
We gotta do them all.
2 and 1. Okay, this is 10.
10.
10
Good
fired.
pop.
10 fired. Great.
Oh, that was good. There they go.
Here's 9.
You've got, yep, you're
9
fired.
fired.
Yeah.
Yep.
IGTs.
And Mongo.
Yeah, sure is.
Got that one.
Yeah.
Keep going. Fired.
It's 11.
11 fired.
Science, you got this?
Yeah, we're on it back here, thanks.
12 is the white one.
I got both of them, but that's okay. Nope.
Group force are you on?
What's that?
You're on group force 9. That shouldn't be happening.
It's just a slippery part of the monofilament, maybe.
There you go.
Fired.
There we go.
Thank you very much, guys.
So was that our last scientific
Cool.
task of
Yep.
the dive, Lee?
Got it.
Sorry, what was that, John?
Was that our last scientific task of the dive?
That was indeed. That was our final
All right, I'm
Forniskin
gonna
side,
secure
so
port
we're
rail
on the way up
camera.
now. Or
Roger.
continuing
Okay.
our ascent.
Port rail camera is off.
Yep, I'm good.
Arm is secure.
Just a nice question on Nautilus Live to the ROV pilots. How much power are we sending down the cable to Hercules and Argus?
Oh, about 2,700 volts.
Okay.
40 amps per leg.
Yeah, 3-phase.
So you guys take a lot of precaution. Well, when do you actually go live with the power? Is it while they're still on deck?
We do a high voltage test on deck,
Right.
Which we have a protocol for, and then we go actually live when Hercules is still on the hook on the crane,
Okay.
but over the side,
Right.
oftentimes in the water.
Right.
And then we will, but Argus is still on deck and has high voltage.
Right. So another question on Nautilus Live. It's always nice to have the time to go through these on the blue water shifts. How long would it take to boil an egg on an undersea vent? Well, it kind of depends how hot the vent is.
Depends on the vent.
Yeah. I mean,
The real trick is getting the egg down there, though. we have brought down eggs.
you have not
Yep.
They can't. Sorry, I can't hear you, Gabby.
They come back uncracked.
How does that work? Is it because they're incompressible, the fluid inside?
Well, there's a lot of fluid inside. There's a bunch of speculation. There's also air inside, but we
Yeah.
kind of were thinking that they're porous enough.
Oh, so there's fluid flow through the shell that basically equalizes.
I don't know. I think that's what we're thinking.
I
Because they did come back uncracked. We did it on ONC, didn't we?
You're not pulling my leg, are you?
No, we
definitely
did.
not.
We did it on ONC. We put them in the buckets.
And
I
we sent
remember
them
this.
down to like 2,000 meters.
Yeah, they went down a ways. There were a lot of bets as to what was going to happen.
Yeah.
I don't remember if we cooked them afterwards or not.
The question I had was like whether they were salty after.
Yeah, a little bit.
I suspect they
Yeah.
must have been salty if they didn't crack.
Well, I think we were near one of the vent fields, so I think Ruben said that they were sulfury.
Oh, that's fair.
I did not think you guys were going to have an answer to that question, but yeah.
Oh yeah. It's not uncommon
not
for
quite
people.
an answer, but it's a good story.
Yeah.
There's also you can also pressure marinate meat if you
Yes.
send it down. This is not on this ROV, but other ones. I've heard of.
Hypothetically, we've never done that, right?
Oh yeah, hypothetically, yeah.
Well, I worked for a different boat.
They did
one
they did
point.
it on that boat.
Yeah.
So what'd you do? Did you put it in a Ziploc bag with the marinade and just
Yeah.
send
Yep.
it down? And
Yeah.
Okay.
You could send down a bag of Lay's potato chips and you'd come back with like a brick and like half a cup of oil.
Oh, have you done that? Well, but the bag's full of air.
Yeah, but it's all in Ziploc. It just
You just have to watertight it. Oh, okay. Oh, the air just all
compresses. Yeah.
Gotcha. You don't pop the bag.
Right.
Compress the air. I got it. I follow. That's rad.
Yep. Sent down a couple of candy bars one time.
What happened with the candy bars?
Well, one of them was called a crunchy, which, unless I think you've been into the South Pacific, you don't really know about.
Okay.
It was like one of the few candy bars we could get supplied to the ship. And it was really kind of like, I don't know, it was kind of like syntactic foam wrapped in chocolate.
Yeah, we've had that in Britain. Yeah, that's something I remember growing up in Britain. Yeah.
Yeah.
Oh,
It's basically lots of air inside it.
I
Yeah.
love that you understood what he was talking about based on that description.
Oh wait, that stuff's awesome. It's like baking soda in molten sugar.
Yeah.
Yeah,
that's
just
right.
like bubbles up.
And then,
Syntactic foam.
Yeah, covered in chocolate.
And so we
It's
sent
fantastic.
it. We sent it down, and it came back just liquefied.
Oh, really?
Yeah.
Gross.
That's really
Nobody wanted to
interesting.
eat it, but it was just like we didn't even open the bag. It was just squishy.
That's super interesting.
We sent that down on a Remus. But no, when I worked for a different group and we had a manned submersible, if it was steak night on the boat, steaks got marinated.
That's excellent.
Nice and tender, I guess.
Yeah, it's kind of like the now they have those needles for flavor injection. You can inject the marinade inside the steak. It's a more expensive version of that.
So one thing I didn't see this morning at launch is did any of the styrofoam cups go down on Argus?
They
They're
sure
all
did.
on Argus.
Okay,
The styrofoam heads and the styrofoam cups.
cool. I actually saw that somebody made a styrofoam Enceladus.
A styrofoam what?
Enceladus, the moon of Saturn.
Oh.
Huh.
What is specific? What's so identifiable about Enceladus?
Well, Enceladus is one of the locations in the solar system that we think has large bodies of water underneath the ice sheet,
Right.
Liquid
Okay.
water, right? We don't know if it's an ocean or if it's just large reservoirs. And, I mean, the idea is that these moons are actually heated by frictional heating. They get squashed and squeezed as they orbit their parent planet, Saturn, or in the case of Enceladus,
Oh,
or
wow.
Europa in the sense of Jupiter. And as they orbit, literally they get squashed and squeezed, and that creates frictional heat inside them. And then where you get the analogy is that, well, where does most of that heat on Earth make it through to the surface? We used to get very confused because the heat through an average part of Earth's crust was way too low. And then we discovered hydrothermal vent systems, and these are like heat short circuits where lots of the heat from the center of Earth
Can
Make-
make it straight to the A short circuit is a great analogy.
Yeah.
That's really cool.
And so we don't know that there are hydrothermal vent systems on these moons in the solar system.
But we suspect.
Yeah, but we think it's a good working hypothesis. And so...
For how you melt all that ice. And you're saying that Enceladus has liquid water, not liquid methane or liquid something else.
Liquid water. So it's got on the outside, it looks like a golf ball, right?
Okay.
So that's solid water. Okay. And then...
Solid water.
essentially, what we then see coming on Enceladus, it's really neat. Basically, there's a few cracks in the south pole of Enceladus, and you can see geysers of water vapor and water ice crystals coming out from underneath. And so something's got to be powering that. It's not quite right to call it volcanism. We call it cryovolcanism, so low temperature geological effects. But yeah, the science of how they infer the presence of these liquid water, sometimes oceans, sometimes let's call them seas, is it's very elegant, it's very beautiful. But yeah, so that's the reason why one of the styrofoam balls has been modeled as Enceladus and will come out as a tiny Enceladus, hopefully later this dive.
That's really cool. So why does it look like Enceladus? Does it just look like a golf ball?
Well, Enceladus, it's amazing. It's a moon that's about 500 kilometers across, and it looks like a golf ball. Right? Even down to the dimples. On about 50% of the surface is covered by all of these impact craters. And so, you know, looks a little bit like the surface of a golf ball. What we don't quite understand is that another part of the surface is really smooth, like an eggshell. That means that not that it's all the impacts miss that particular region, but that something must have happened geologically on the surface to then repave it. And on Earth, you think about, okay, that's lava, that repaves the surface. On Enceladus, it's probably more correct to think about liquid water or slushy ice as the analogy to lava. So it really, it takes all the familiar concepts of Earth and applies them, but in all these different temperature ranges.
Cool. That's really neat.
But yeah, I tell students you could drive across Enceladus if there was a highway in about 4 or 5 hours. That's how small it is.
Still bigger than Rhode Island.
Yeah, the distance I'm used to is it's the distance from Vancouver to Kelowna, more or less.
Oh, okay.
Yeah.
BC is giant. I think of BC as being
BC is big, yeah.
Humongous.
Yeah.
Distances out in BC are just too large for me to imagine with my little Rhode Island mentality.
Okay, this is the other cool thing about Nautilus Live. So somebody remembers on Nautilus Live the egg going down.
Oh, great.
And apparently, when it was cracked, it did smell horribly of sulfur, and nobody was brave enough to eat it.
Oh. Who was that? That's very impressive. I mean, we were on that cruise and we don't even remember this.
Yeah, but sometimes you're asleep when it happens.
Yeah, totally.
Yeah. No, that was, I don't think they were on the cruise, they were watching it, but that's thanks to Jack in Toronto for that.
Nice, thanks, Jack.
But you're right, if it's smelling of sulfur, then I think the vent fluid has to be getting close to it and permeating in there. That was the one thing I didn't check 2 years ago. I actually got a big chunk of hydrothermal vent chimney that landed in the front porch of Hercules and came to the surface. I didn't smell it.
Oh, really?
But it should have smelled of sulfides.
Yeah, sometimes when you get like sediment cores from those sites, they're
they smell so
pungent.
bad.
Yeah, those ones certainly. Because I guess you're bringing up the bacteria as well inside the sediment sample. So for those of you who might be just joining us on Nautilus Live, trying to check out what's happening in the evening here on the Nautilus, Our vehicles are currently ascending back to the surface. We expect to have them back on deck somewhere between 8 and 8:30 this evening. We've had a pretty full, pretty exciting day here at Gorda Ridge. Gorda Ridge is a section of the Earth's crust where we have two tectonic plates spreading away from each other, the Pacific Plate and the... Oh! Nice little jellyfish there floating in the water column. I guess that shows our ascent rate pretty well. So this is a...
Slow.
Yes. So this is a region where the Pacific and the Gorda tectonic plates are spreading away from each other. That crack in the Earth's crust that is formed is a site of varied and sometimes intense hydrothermal vent activity. We spent a good portion of the day rediscovering that site, if you like. It was last visited by a scientific team in, I think, 2006. So our first task of the day was to relocate the vents, and then we spent part of the day mapping them in quite some detail with a really novel high-resolution sonar system that's mounted on Hercules. We've started to do some physical measurements of temperature of the vents and dropped off a couple of microbial experiments. Due to the nature of how we put these cruises together, we have a pretty regular daily schedule, so we like to have the ROVs back on deck by about 8 o'clock each evening. That gives the ROV teams...
8 to 9.
Yeah, 8 to 9.
8 is ideal, 9 is likely tonight.
Right. Thank you. And then the ROV team is going to work hard to prep the ROVs for a pre-dawn launch at 4 a.m. tomorrow morning, and then we're essentially going to go through a very similar daily schedule, dive down to the site, taking 2 to 3 hours, and then we have another busy day of experiments and measurements planned down there. I don't know if our backroom team has any highlights they want to pick out for us, but we'll be hopefully tomorrow starting to measure some vent fluid, trying to filter out some bacterial samples, maybe do some geochemical measurements. If you see the front porch of Hercules at the moment, you can see basically an apparatus that looks like a series of steel tubes or titanium tubes bolted together. That's an IGT, or an isobaric gas trap. What that device is designed to do is to sample vent material, but vent fluid, but to bring that fluid back to the surface for analysis, but all the while keeping it at the same pressure it was while it was at depth. And what that means is all of the interesting gases that might be trapped in the vent fluid that reveal the geochemistry of what's happening in the heating zone underneath where the vent is, will be preserved in solution, and then they can be extracted under controlled conditions and then measured to see what kind of quantities and different types of gases we've got in there. Hopefully that's something we'll be doing tomorrow. And then, weather permitting, we're going to follow that daily pattern of dives, I think for the next 8 or 9 days. And so we're all keeping our fingers crossed for low swells that mean we can launch and recover each day. And we should make a lot of progress at this site. So sat next to me is Wayne, our video engineer, and I was just going to ask you, Wayne, do you have any highlights from the day? We saw some pretty neat things down there.
Yeah, I think the diffuse flows were really cool.
Uh-huh.
The way they optically made it made focusing challenging, and you couldn't see through them quite well, and how to find them. It was just fascinating. I really enjoyed seeing that, and there were so many of them.
Oh yeah.
You know, there was some low flow ones that had certain properties and weren't as hot as the high flow ones, and the really high flow ones had solid material, and those were the chimney smokers, and you know, the neatest part about it for me is we knew to look for them here because they were seen 10 years ago.
Uh-huh.
This has been going on for 10 years.
Oh yeah.
It's like someone left the faucet on, you know, for 10 years. Yeah, and probably longer than that, probably hundreds or thousands or millions of years.
Well, it's interesting that if you try and run the maths and you say, okay, these off-axis vent systems are about 300 meters away from the main center of the main spreading center where a lot of the activity is. And then, I guess, from geological measurements, you can try and measure the age of the rocks as they get further and further away from that spreading center. And that gives you an estimate of kind of how fast that conveyor belt of rocks is running over time. And I believe I'm right in saying, I read through some of the literature on this, that if you do